Apple's M4 Mac Mini has been making waves since launch.
While I can objectively say that the base model M4 Mac Mini is the absolute best value desktop PC on the market right now,
but I wanted to see how all these machines stack up for software developers. So today I'm testing interpreted code, compiled code, and of course, how can we do a 2025 video without doing some LLM and AI stuff? Let's just call it machine learning. We know what it is, right? Come on. Now let's check out the machines that I'm testing here, and I've split this up into two tiers, the premium tier and the budget-friendly tier. These are in the range of $500, including the Mac Mini, and these are in the range of $1,000, and that Mac Mini M4 Pro is the base model. It's $1,399. You know, it's a little bit higher than everything else. As far as the budget-friendly machines, these first two right here have the same Ryzen 7 8845HS chip inside, but very different capabilities. This is the Beelink Sir 8 machine, a pretty decent little computer. And this is the GMK Tech K8 Plus. It also has the same Ryzen chip as I mentioned, but this one has Oculink on board, which allows you to use an eGPU to extend this little mini PC with insane performance for machine learning. We'll look at that later. Here we've got the Minis Forum UH125 Pro. This is using Intel's Core Ultra 5, so it's not a powerhouse by any means, but we'll see how it does. And we've got the Mac Mini M4. This is the base model for $599. It's little, yet pretty powerful, as we've seen. Speaking of Mac Minis, we'll jump over here into the more premium tier. That's the Mac Mini M4 Pro. By the way, neither of these Mac Minis have an external power brick, making them smaller and lighter than all the other mini PCs, which do have a pretty gigantic power brick. Maybe it has to do with that power button. I don't know. Maybe they're somehow related. All the other machines have a power button that's easily accessible, but the Mac Minis don't. Is that related? Bruh. One other thing you can do with the Mac Minis that you can't do with the other machines is build for iOS and macOS. You need Xcode for that. You need to build that on Mac. So the Mac Minis will allow you to run Windows, Linux, and macOS. You can cover mobile development for iOS and Android on those, whereas on the other machines, you'll only be able to develop for Windows, Linux, or Android. Now, moving on. This is the Snapdragon X Elite Dev Kit. This machine is no longer in production, but it offers a sneak peek into how this chip will handle in a mini PC form factor. Mini PCs with X Elite chips are gonna hit the market in 2025. You'll see. Finally, we've got the Beelink Sir 9 with an AMD Ryzen AI 9 HX370 in there. It's not a cheap, but it is a powerful mini PC featuring AMD's impressive new CPU, which I've had a chance to work with extensively for the past few months. Both the GMK Tech K8 Plus and the Beelink Sir 8 have a Ryzen chip in them, and they're both registering about the same, just sitting there idling. However, both the Apple M4 and the M4 Pro are using the least amount of wattage, just sitting there idling. 3.7 for the M4, 4.2 for the M4 Pro, and the others here are X Elite, Beelink Sir 9. This is the second best next to the M4s. And then we have the third best, which is the Intel Core Ultra 5. Pretty good on the idle. Ideally, these are all show close to 0 or 1, but yeah, you know, you get what you get. It's not a perfect world. All right, now you know the cast members. Let's get on with the show. I decided to kick things off with Geekbench because everybody knows this, and it's a good comparison point to kick things off. This one, unfortunately, I have to trigger one at a time. I have to switch between the computers with my little custom KVM setup, but that's okay. I signed up for this. You didn't sign up for this, so you don't have to watch this part.
A few moments later.
Geekbench finished up, and this gives us a basic idea of what we're dealing with for processing power here. Of course, the M4 family has the highest single core operation test results, and we're talking about 3,972 over here for that M4 Pro, up to 20,000 multi-core score for that M4 Pro. That is the 14-core variety, which is pretty crazy considering it beat out all the other machines just like that, including the Snapdragon X Elite Dev Kit, which has a pretty high score, single core at 2,977, and multi-core 15,532, both pretty good. But right now, if we're taking into consideration the price point of these machines, the X Elite came in at about $1,000 and the Mac Mini M4 at just $599. And the multi-core scores on those two are pretty much the same. However, the single core score on the M4 blows away the runner-up, which is the X Elite machine, which has 2,977 as the score. Now, for the other machines, we've got the pretty pricey Beelink Sir 9, which has a really nice multi-core score. And from my testing, it's probably one of the smoothest Windows machines I have. It has pretty much the same exact scores as the the X Elite machine. X Elite up here, Cer 9 down here, and they are about the same price. Of course, this is x86 architecture, this is ARM architecture. I've got faith, and slightly lower scores on the Beelink Cer 8, the two Ryzen machines, this one and the GMK Tech Knockbox K8 Plus having about the same scores. Makes sense because it's the same chip in there, although the GMK Tech edging out the Beelink just by a tad bit. Minus Forum has a weird name. Never knew that's what it was called, but hey, here we are. The worst showing of all bunch, and that's the Intel Core Ultra 5. I feel for Intel though. They've had a rough year. Now, whenever I run any test, the X Elite machine unfortunately starts making the most amount of noise. I thought we got away from that, but here we are. And also pretty unfortunate, it got one of the lowest scores. Now, you might be wondering if I'm running the ARM version of Chrome on that machine. Yes, I am. I am running the ARM version of Chrome. It didn't do so well. I don't know. We've had higher scores on the X Elite laptops that I've tested before, but this is actually the first time I'm testing the Mini PC desktop, which is the dev kit. 45 for the M4 Pro, 47.8 for the M4 base model, and everybody else is kind of trailing behind except for this one, which is the Cer 9. I told you this little guy is really good, 31.5. But as you can see, the M4s left the other machines in the dust. All right, you've seen these speedometer tests before. Nothing crazy, nothing new, but let's get into the nitty-gritty stuff. After all, this is a video with a little bit more details. And a nice transition point would be something called Web Tooling Benchmark by the V8 team. And I'm also going to switch over from just running pure benchmarks with nothing else running the machine to something a little bit more realistic. After all, we don't just have one thing running on our machines. We have browser open, we have an IDE, we have terminal, other stuff. So I'm gonna match everything on all these machines, and I've got 17 tabs in Chrome. I've got Llama, LM Studio, VS Code, 2 instances of that, Notion, and a couple of terminal windows open. Your situation might be a little bit different than mine, but this is kind of like my usual setup. It's not over the top, but it does show a few things being used at the same time, and these machines can all handle it just fine. Now that the base model Mac Minis also have 16 gigs instead of 8, all these other machines have 32 gigabytes of RAM. Even with all that stuff open, we're not using that much power. Here are the more expensive machines. M4 Pro, X Elite, Beelink Cer 9, and here are the cheaper machines. M4, Minis Forum, GMK Tech, and Beelink. None of them are using significantly that much more power because nothing is running. Programs are open, but it's still kind of idling. However, the Mac Minis are definitely showing a lot less power used. Web Tooling Benchmark. Now, a tradition on this channel is to use this thing, well, multiple ones of these, and to automatically push the enter key, but I don't have enough of those. By the way, I'm not gonna say the name of this because my videos have been flagged for that before. Weird. So this guy's gonna stick around for other videos. But I came up with another solution, and this one is called Son of Arnold. It's still a fun and manual solution where I get to push a button, but the prototype is USB based. These are all seen as a keyboard by all these machines, and when I hit this button, it registers the enter key on all of them at the same time, allowing me to do races. All right, everything is ready. All I gotta do is push this red button, and all these machines are going to run this command all at the same time. This is the first time I'm doing it, officially. More to come. Let's go. Oh, I love that. That is awesome. It's actually working. Who is gonna be first? I love watching the races. It's just so much fun. I see that the M4 Pro is leading. No surprise there. But the M4 is pretty tied with the rest of them. Now, as a side note, while that's running, thank you to the members of the channel. This video does not have a sponsor, but it does have members. So thank you to the members. And if you want to be a member as well, there's a join button right down below. Otherwise, subscribing is free. All right, let's see.
12 seconds later.
I think the M4 Pro finished first, but we have a little bit of a, one of the machines just gave up, said, I'm not showing that. The results are all over the place. Wow. But the winner by far is the M4 Pro. The geometric mean is 33.08. That's the M4 Pro. The M4, 32.28. Now, because these are web benchmarks, there is mostly single core operations going on here. And as we've seen, the M4s dominate in single core. Shortly, I'm gonna call the M4s first, even though it's two separate machines, but they are using the same kind of core. But the second is the X Elite with 22.59, and then everybody else. What about a more realistic example? And for that, we've got an extremely large JavaScript monorepo project. This is created by Victor Sofkin. I've shown this on the channel before. The repo contains 5 shareable, buildable packages and libraries with 250 components each, 5 Next.js applications built out of 20 app-specific libraries, and each library has 250 components each. Yeah, a lot of stuff. About 26,000 components total. Now I'm gonna build one of the apps, and the command for that is, on Windows, you have to use measure command. It's a PowerShell command so you can get the timing, and then nx build crew, skip nx cache, because we're gonna be skipping cache so we can rebuild everything. But on Macs, the command time is built in, so we're gonna use the time command for that. And this is another race, because I'm gonna be using this as much as possible, because I really like this thing. Let's go. Wow, that noise is coming from this dev machine over here, the X Elite. I kind of missed the winner, but this was too fast. It's not really a race, it's just for fun. But the M4s each got 7.7 seconds over here on the M4 Pro and 7.3 seconds on the M4. The next closest one is the X Elite with 12 seconds. Then the Beelink Sir 9. We've got the most expensive machines, of course, being the fastest, except for the M4 Mac Mini, which is just as fast as the M4 Pro in this case, but it's not expensive. And then the cheaper machines, the $500 range machines, are all over 16 seconds. Well, this one is 15 seconds for the GMK Tech. The Beelink is 17 seconds, and the Minis Forum is 16 seconds. Now, the JavaScript tests were all based on around a single core performance kind of workflow. Even though some JavaScript tooling does have multi-core involved, those mostly were single core. But here we're gonna test some multi-core performance in the real world. Specifically, I'm going to run this Mandelbrot algorithm, which I got on Benchmarks Games. And if you're not new to the channel, you've seen me run this many times before. What's nice about this Python program is that it uses all the possible cores all at once. So naturally, the machines that have more cores should do better, right? Usually that's how it works. But let's see how it is in the wild. And this one is gonna be a race. Now, because this is gonna be a pretty intense test, I want to measure the power, the min and the max that all these machines use during this test. So I've got these little handy power meters, which I'm going to reset all of them. And this way we can get a nice clean reading. All right, I think we're ready to go, and boom. Away they go. It's about to get real warm in here. So while this is running, oh wow, I was not expecting this at all. The X Elite machine, it is a dev kit after all. It's making the most noise, but this is what I was not expecting. It's for it to be using so much power. Okay, we're almost done. Just waiting for a couple of these over here, and I think we're almost done. Here we go. Let's review the results. First of all, the power usage. I want to check that out. So the highest power usage, M4 Pro went up to 80 watts. Wow. The X Elite went up to 137.9 watts. The Beelink Sir 9, 78 watts maximum. M4, 38 watts. 81 watts for the Minis Forum with the Core Ultra 5. 78.3 watts for the GMK Tech. And I'm expecting the same for this one. Close, 76.7 watts for the Beelink Sir 8. And here's the low wattage for all these, which is pretty similar to what we've seen before, except this one is kind of an outlier, the Sir 8. I think that's probably a measuring mistake. It cannot be that high. I've already showed you what that one is at idle time, so 25 is a little bit high. Now let's review the actual results for the timing. And in this case, the M4 Mac Mini does not beat the fastest machine being the M4 Pro, with 23.2 seconds total. The second fastest machine is the Beelink Sir 9 with 28 seconds, followed closely by the X Elite dev machine at 28.8, and only then we get to the M4 Mac Mini at 31.4 seconds. Then only 10 seconds later we get the GMK Tech at 41.4 and the Beelink Sir 8 at 42.7, and a bit later the Minis Forum with the Intel Core Ultra 5 comes in at 46. And I'm making that voice because it's sad. Pat, we're gonna miss you. Pat was a good guy. He got a raw deal. Moving on. Running Python as interpreted code, what's it like to actually build code or compile code? Let's look at a project here. This is a CMS, Umbraco CMS. You might have heard about it. Maybe not. Maybe if you have, let me know in the comments down below. This is an oldie but a goodie. I've used this in the past for actual projects. And it's completely open source, which is why I can grab this source code and build it. And it's a nice, pretty decently sized project. So this will give us an idea of what it's like to build a real application using .NET. We're using .NET 9 here, which is cross-platform. It's gonna work on ARM, it's gonna work on Macs, it's gonna work on PCs that are x64. So that's why it's good for us right now. All right, I've set this up to build on all these machines, and it's the next day, so I hope this still works with my son of Arnold here. Yeah, I'm wearing the same clothes. Continuity, okay? I just broke continuity by revealing that, but whatever. This is YouTube. Okay, we're ready to build this thing on all the machines, and let's go. It's doing it. It's building. Well, we've got one winner right there, and they're done. Sorry for the close-up. It's a zoom lens, okay? We have a significant difference between the M4 Pro and the next runner-up, which is the M4. We got 84 seconds on the M4 Pro to do this build from scratch, by the way. This is not a subsequent build where things are cached. And then we got 93.9 seconds on the M4. Again, they're leading the pack. This little $599 machine is beating out machines that are $1,000 and all the other machines in the same price range. The next runner-up is the X Elite machine, 119.9 seconds for that build. No surprise, the Beelink Sir 9 comes in after that at 149 seconds, followed by the GMK Tech K8 Plus, 154 seconds, and the Beelink Sir 8 after that, 161 seconds. And bringing up the tail again, the Minis Forum at 166.9 seconds with that Core Ultra 5. I also wanted to simulate a very large project. So I'm generating 100,000 namespaces and classes over here. And they're not just empty, they have operations inside of them, like recursive calculations, nested loops, array processing. That way the compiler doesn't just skip over these and actually builds every single one of them. So this is a pretty large project, and I'm gonna build it now. And of course I'm gonna use Son of Arnold. Why not? It's fun. Let's go. And there they go. Here we go. They're generating the files, and this is pretty crazy. There's the generated code folder, and there's all the namespaces in there. It's just a lot. And inside the namespaces, there's a class with some of the code that's inside each class. Now we're at the building stage. Some of these are restoring NuGet packages, but these guys are ahead over here. Listen to that. That is crazy. Yeah, it's you. Surprised at you. Even this Intel machine is not making that much noise. And Intel is known for noise and heat. The other loud machine here is this GMK Tech K8 Plus. However, it's very smooth, white noise almost kind of sound, just steady. I wouldn't mind having any of these machines in my office, sitting on my desk, except for the Snapdragon X one, the dev kit. Okay. 2 of these have finished already. And this one, yeah, wow. This is the first one where the Snapdragon X dev kit beats out an M4 family member. Remember, that's .NET for ARM over there, on Windows on ARM. ARM-based processors are really doing well this year. I'm really hopeful for that architecture to keep going and continue, especially in the Windows world. We know it's gonna happen in the Mac world, it's already happening, but in the Windows world, this needs to happen. We've got results for everybody now. Let's go over it. By the way, the Beelink Sir 9 also beat out the M4. Interesting. So we're gonna go backwards this time, okay? The longest one is our Minis Forum with the Core Ultra 5 in there. That took 123.5 seconds. Then the Beelink Sir 8 with the Ryzen chip. Now the M4 Mac Mini has the least number of performance cores here. It only has 4 performance cores and 6 efficiency cores, but this is definitely a performance core operation here. And that's why we're seeing these kinds of results. So if you have this type of setup and you buy the M4 as opposed to the M4 Pro, you're gonna see a little bit of a difference. And mind you, this is on a very large project, so you're gonna have to be doing something like that in order to feel a difference. So 106 seconds on the M4, and that one is beaten by the GMK Tech K8 Plus at 101 seconds. Next is the Beelink Sir 9, 91 seconds, pretty good, and 86 seconds on the X Elite dev machine, very nice. But of course, our winner is the M4 Pro, as usual, 66 seconds here for this build. So the difference between the fastest and the slowest is twofold here, more than twofold. Let's switch gears for a bit and talk about ML, or better known as these days AI. AI. I want to start with a little bit of training. Not that these machines are really meant for training. You're not going to be doing training on this, but I want to show you something. And this is very important. PyTorch, by default, one of the very popular libraries for doing machine learning, detects MPS, which is metal performance shaders, or Apple's way of saying GPU. So when you run PyTorch for training, and here I'm doing ResNet 50, which is a 50-layer architecture using the CIFAR 10 dataset, PyTorch will automatically detect it, and it'll be significantly faster running on the GPU than on the CPU. So this is how I ran my training. It first downloads the training set, and I only ran a subset of it, not the full training, because that's going to take forever, especially on the CPU. But if we take a look, while this is running the subset, there's the memory pressure. It went up. We got 16 gigs of RAM on this machine, and it's using almost all of it. Furthermore, if we take a peek at the GPU history, you'll see it right there. There's that spike using the GPU. And that took 31 seconds on this M4 base Mac Mini. Now, it didn't go much faster on the M4 Pro. 28 seconds over here. It's a little bit faster, and that's because we're not looking at CPU performance cores here. We're using the GPU, and there's 10 GPU cores on the M4 and 12 on the M4 Pro. Not a huge difference there, and that's the result here. So if you're gonna be targeting the GPU, you're really gonna be looking at things like the M4 Max, which has a lot more cores, or the M2 Ultra, still in the M2 generation for now. And that one has way more cores, a ridiculous amount of GPU cores, so it'll crush this task. That one you might be able to do some training on, but still, probably not. Here are the rest of the results. I already ran this. The machines that did the best running this on the CPU are the two Ryzen machines. The Beelink Sir 8 finished that task at 97.7, 99.4 seconds for the GMK Tech K8 Plus, 111 seconds on the Beelink Sir 9. It's slower on the Sir 9 than the Sir 8. That's interesting. That machine costs twice as much. Then we've got the X Elite machine, 157 seconds. That took a while. And finally, Intel Core Ultra 5, 187 seconds. That one was the slowest. No surprise there. But I do have to say something. Each one of these manufacturers, I mean the chip manufacturers, Intel and AMD and Snapdragon, have their own custom libraries to do machine learning. I did not install those libraries, nor did I write my code in order to utilize those libraries, which you could do. And I've made videos specifically for the Intel version, and I've got a couple on AMD coming up, on how you can utilize those libraries and target the GPU, the internal GPU of those machines, so you can get more speed out of your machine learning tasks. Now, one thing you could do with some of these machines is you can add an RTX 4090 or whatever GPU you want from NVIDIA. If you're using NVIDIA, you're going to be programming against the CUDA interface. Here I happen to have the 4090 connected through Oculink to this GMK Tech K8 Plus, which happens to support Oculink right on the front. It's got an Oculink port, and now I have two GPUs available. One is the internal GPU, the AMD Radeon 780, and the other one is the NVIDIA GeForce RTX 4090. And I can run this training on the 4090. So this is gonna be a little bit different. Watch this. All right, the 4090 didn't even spin up its fans. That's how fast that training was. 5.6 seconds. So yeah, different capabilities. With the GMK Tech and this Minisforum, the ones with Oculink ports, you can do that kind of thing. With the other machines here, you cannot plug in an external video card through Oculink like this. Now, like I said, training is not the thing you're gonna be doing with this. You're most likely gonna be doing inference, which means generating things like text and using it for coding. Now, I have other videos showing how to use LLMs with coding, but here I'm just gonna show you a couple things. One is that this tool called LM Studio, a pretty popular tool. When you load a model, let's say I wanna take this llama 3.23 billion parameter instruct model, you can offload a certain number of layers to the GPU. And this tool will automatically detect and run things. It already has libraries built in that'll take advantage of the internal GPU. So we're gonna check out how this works with the internal GPU on all the machines now. LM Studio, by the way, is also available for the Snapdragon X Elite platform, specifically for Windows for ARM, so it can do that one too. And also, if you do wanna switch between the CPU, the GPU, or the external GPU like I have here, LM Studio lets you do that. Under developer, you can go to LM runtimes, And here you can select CPU to force it on the CPU. Why would you do that? It's going to be slow. If you have CUDA available and you have Vulkan available, Vulkan, by the way, is the ability to run on the internal GPU of this Ryzen machine here. And CUDA is going to be using the external GPU. So you can choose which one you want to your heart's content. We're going to start off with the internal GPU here and load this model up. Now, I do want to show the best possible scenario for all these without having to buy extra hardware like I have here. So for the best possible scenario for the Max is using MLX. Some of these models are built for MLX, which is Apple's PyTorch equivalent framework, and it's very optimized as opposed to the GGUF version, which I'm gonna run on these other machines. So yeah, I guess it's kind of cheating, but if it's available and it's on board without having to buy extra hardware, then why not? By the way, I'm throwing terms around like MLX without going into details about that in this video. Just trust that I'm using the right libraries for these. I go into more details on these libraries in other videos. There's just no time for doing that in this video. I'm set up on all these. It's gonna write a 1,000 word story for me. It's about to get real hot in here. And of course, son of Arnold, here we go. And boom. Nice. There they all go, writing the stories. And why is this one spinning? Whoa, the X Elite machine just took off. I'm not sure why this one's working. It's not supposed to be, but we'll see if the result is really different for this particular machine, which is the GMK tech, and we'll know what happened. All right, well, they're done. Let's take a look. The M4 machine was done a long time ago. Yeah, the 4090 was working on that one. But that's okay, because it doesn't matter, since the GMK Tech and the Beelink have the same exact processor and the same internal GPU. We'll get to compare side by side what that internal GPU is compared to using Oculink with RTX 4090. So speaking of the Ryzen machine, the Beelink Sir 8 ran that at 27.8 tokens per second. This one's still going, by the way. That's the Intel machine. I'm starting to suspect that maybe LM Studio doesn't have the right Intel-based library in it to be able to generate this fast enough. That's just ridiculously slow. The next fastest was the Beelink Sir 9, 32.56 tokens per second. Then the Snapdragon X Elite at 36.11 tokens per second. I'm sorry if that's hard to see. Trying to get this camera as close as possible to it. Ooh, that Intel one finished 7.09 tokens per second. Definitely not good. So here we go. The M4 using MLX, 46 tokens per second. That's the base model M4. It's not that much faster than, let's say, the X Elite, which is just 10 tokens a second behind that. But over a long period of time, I guess that's gonna add up. Now, what is a lot faster is the M4 Pro. 101 tokens per second on that one. And you know what else is a lot faster? The RTX 4090, 176 tokens per second on that one. I wonder why it used it and didn't tell me about it, even though I had Vulkan selected. Now, just for kicks and giggles, let's select CUDA over here as my runtime and do that one more time. Whoa, there it goes. And the fan started spinning up. 150 tokens per second. It's done. So yeah, pretty fast. Now, if you haven't seen my video on how I set this little NUC box, this is the GMK Tech K9 with 96 gigs of RAM to run machine learning, check out this video right over here. Otherwise, thanks for watching and I'll see you next time.